So our properties of exponents. There are 7 total properties that you have to know and you have to be able to apply and use whenever it comes to our exponents. It's important to know your properties because when you get to Math 2, you're going to have to apply them because you won't always be able to expand them out. So let's review what we've learned. So the first property was the product property, which says if you have the same base, you're supposed to add your exponents. So 2m squared times 2m to the third. Well, the first thing I want you to notice is you have 2 total bases here. So notice how you've got a base of a 2 and you have a base of an m. So I can actually use my commutative property and I can write my 2's together and call it 2 times 2. And then I can put my m's together. So here is the m squared. And this is the m to the third power. So 2 times 2 is 4. So same base, add your exponents. So it becomes 4m to the fifth. This one, the next one, is your power to a power. If you remember, your power to a power says that you are allowed to multiply your exponents. So this becomes a to the 6 because it was a to the 2 times 3. Well, why is that? Why does it work that way? Well, I have 3 groups of a squared. If I have the 3 groups, and in every group I have 2 a's, well, notice how I have a 2 times a 3. So I have a to the 6th power. Now, what we also learned using that foldable was sometimes we have more than one thing in parentheses. So this one's a lot like the power to the power, only the rule says to distribute the exponent to everything inside the parentheses and multiply exponents when necessary. So I have to distribute the 2 to the negative as well as to the 4. I have to distribute the 2 to the a to the 4th. So it becomes 4 times 2, which is 8. And then I have to distribute the power of 2 to the b to the 3rd. So 3 times 2 is 6. And the reason why I wrote the first one this way is because that 2 is also going to go with that negative. Because this is the same thing as saying negative 4 times negative 4, or 16. So it becomes 16, a to the 8th, b to the 6th. So let's look at that in expanded form. So I've got 2 groups here. So I've written it out twice. Now I'm going to use my commutative property to write what goes together, or to write identical bases beside each other. So the negative 4's go together, a to the 4th, a to the 4th, b to the 3rd, b to the 3rd. And if I need to expand it out, I can, but negative 4 times negative 4 is 16. Well, if I've got 4 a's and 4 a's, that's going to give me the 8, 3 b's and 3 b's. That's going to get me the 6. So now our next property, power of a quotient. Okay, well this one's also very similar to power of a product. So the rule says to distribute the exponent to everything inside the parentheses, both on the top and the bottom, and multiply when necessary. So this now becomes 7 to the 3rd power over 2 to the 3rd power, a to the 3rd power, b to the 3rd power. Well, when in doubt, expand it out. So I have 3 groups of 7 over 2ab. and then use your commutative property. Put what goes together together. So the 3 7s on the top, the 3 2s on the bottom, the 3 A's, and the 3 B's. Now, our quotient rule. So if you remember before, quotient means to divide. So when we're dividing, if we have the same base, we're going to subtract our exponents. So this becomes x to the 6 minus 4, or x squared. When in doubt, expand it out. So I have the 6 x's on top. I have the 4 x's on the bottom. And anytime I'm dividing something by itself, it cancels out and it becomes a 1. So all the x's that are on the top cancel out with the four of the x's on the top cancel out the 4 x's on the bottom, leaving me with the 2 x's on top and the 1 on the bottom if you want to write it that way. But we just call it x squared. So that leads us to anything to the 0 power. So now I have x to the 0 power. Why is x to the 0 power have a value of 1? Well, we're going to work backwards for this one. So what if I had x to the 3rd over x to the 3rd? Well, using the rule that we just learned above here, so subtract your exponents, so that's equal to x to the 3 minus 3, and 3 minus 3 gives us x to the 0, which also has the value of 1. Okay, well, let's expand that out. So the 3 x's on the top and the 3 x's on the bottom. Well, x divided by x has a value of 1. X divided by x has a value of 1. X divided by x has a value of 1. 1 times 1 times 1 is 1. So anything to the 0 power is always going to have a value of 1. And so now that goes back to the move it to lose it. So what does x to the negative 2 have a value of? Well, I'm not allowed to have negative exponents, so I move it to lose it, so it becomes 1 over x squared. Okay, well, let's look at an example. What if I had, for example, x to the 5th over x to the 7? So if I go by my rule of subtracting my exponents, it becomes x to the 5 minus 7, which is x to the negative 2. So why is it that it becomes 1 over x squared? Well, if I have the 1, 2, 3, 4, 5 x's on top, with the 1, 2, 3, 4, 5, 6, 7 x's on bottom, x divided by x is 1, 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 x divided by x is 1. So what does that leave me on the top? Nothing's on the top, or, well, when they all cancel out, you have a 1 on the top with an x squared on the bottom. So then what about this one? What about when it's 1 over a to the negative 3? Okay, well, notice now how my negative exponent's in the bottom. Not allowed to have it. Move it to lose it. So we're going to move it to the top. So that becomes a to the 3rd power. Fractions gone. Okay, hopefully this was helpful. So the next thing you're going to watch are some examples where we're going to be putting all of these properties together.